Is this on?
Let's get started. We're delighted to have Antoine today. Antoine is going to talk about what it takes to ship a new version of Office, giving us an insight into the challenges they face in their development process.
Thank you. All right, I struggled a little bit with preparing this because I wasn't sure how much detail to go in, how much you guys know about what our typical our typical methods of work are. But anyways, I didn't assume too much, so hopefully this won't be too simplified. One thing I forgot on this slide, obviously, is specifying which company I work for. Should have done that. Just.
We have no idea which company we work for.
Yeah, no kidding. Yeah, at least for us, I guess it's fairly clear. APCO Incorporated, right? Two different sort of major areas I want to talk about. The first has to do with a lot of the upfront and preliminary work we do to design a new version of Office. How do we, what goes into the sort of decisions we make about what features get added, what technologies get used, et cetera, et cetera, et cetera. And a lot about what the challenges are. This is really becoming a huge problem for us, which is actually doing, you hear this all the time, what could you possibly add to Office? We've been hearing it for 10 years, and, well, I figure for the first 8 years it wasn't really true. We could always come up with tons of things to add that people would just jump on and buy and upgrade. But it's becoming more difficult. For one thing, a lot of people use Office these days, and more of our business has to do with upgrading people, and convincing people to upgrade something that they're fairly satisfied with is difficult. So anyways, I'll talk about that, and then I'll talk about how we build Office, how we're organized, what are the processes that we use, what are we good at, what do we suck at, and hopefully you guys can solve all the, fix all of our problems that we suck at. That's my goal for this presentation. Okay, so this whole pizza thing. I lifted the title from another presentation that's just about ordering pizza for 120 million people. But this is sort of what we compare it to, right? If you had to order pizza for 120 million people, what would you do? How do you satisfy 120 million people? There are basically two approaches, I suppose. You could get cheese pizza, go for the lowest common denominator, or you could get the, extra supreme all dressed. I'll let you guys guess which approach we take. But basically, we're faced with this problem now. We have 120 million, by the way, is sort of our legal installed base. Actually, it's somewhat higher than that. We figure at the end of this year it'll be about 200 million. That's the legal base. With piracy, the sky's the limit. It's probably about 3 times that much. But if you look at this, is actually a survey we did recently, just about overall satisfaction with our products. And the good news is that over 90% of our users are at least somewhat satisfied with the product. The full 2/3 of them give us a big 5 out of 5. I'm very satisfied. That's great news as far as sort of our pride and customer satisfaction goes. It makes getting these people to upgrade difficult. These numbers have sort of climbed from version to version, and it's easy to sort of see a correlation between that and sort of the difficulty we have in getting people to upgrade our products. So, what do we face? We have a huge spectrum of customers, from experts to, I'm going to pick up my written notes now, from sort of end users to administrators, beginners to experts. The good news on that is, from studies we've done, the truth is there isn't that much difference between the two. Most, whether you're an expert or a beginner, you tend to use the product about as much, and you tend to use about the same number of features. You'd think experts would be all over the product and using all these different wacky things, but they really don't. Everyone's got their own little favorite core that they use, and it's not. There's not that much difference. Everyone wants us to give them new features, but they don't want the product to work any differently. That's it. We're done. They have basically. This has to do with. The customers really are relatively happy with our product, and the barriers to upgrading are encountered incredibly quickly, unless it feels to us that unless we do things almost perfectly, one little hitch and we'll see a huge drop off in our upgrade cycle. And we've seen this before with things like changing our file formats. Oh boy, big surprise in '97, right? We've always done this every time we ship a new version of Office. the old version can't read the files from the new version. Something happened in the collective psyche of our audience, and that was all of a sudden very clearly no longer acceptable. So we have to be extremely conscious of these things that sort of break. Backward compatibility is incredibly important to our customers. Now, on the other hand, we had a huge percentage of our Office 95 users upgrade to Office 97. So I'll let you, might be that changing file formats has an advantage for us, but we try not to. Well, we promise not to do it, though. Finally, we have these sort of conflicting things that people ask us for. For example, a lot of our end users want to be able to customize the product to death, and their administrators and IT people want to lock it down as much as possible to cut down, training costs and support costs, and so we're faced with sort of dichotomies like that, or challenges, or paradoxes like that are difficult to handle. And finally, everyone wants, there's this perception of bloat in Office that is universal. I mean, heck, I think it's bloated. And everyone, the problem is that obviously everyone has their own set of features that they want. We know, this has been, we've always assumed this, but we've sort of proven it to ourselves through a lot of data and research that everyone uses some very small percentage. Usually about 15% of the features get used by a given person, right? And of that 15%, probably 80% of that is a common core, the things that that everyone uses: open, save, copy, paste. And then the other 20% is all over the map. It covers every feature in the product, right? So everyone has their little 20%. Unfortunately, it's not the same 20%, and there's a perception that the other 80% gets in the way and eats up resources. Frankly, there's a lot of misunderstanding of that. For one thing, yes, it does eat up disk space, no doubt about it. A lot of people think that it's chewing up. That if the working set of the applications could be 20% of what it is if they didn't have all these extra features they never use. Of course, that's not really true. The one thing before I go any further here, I mean, interrupt with questions. It works better that way than to just stack them all up for the end and then sort of forget. Yes?
So Office has things like Excel and Word and PowerPoint, right? Do you get the same kind of requirements and data for all of the underlying?
Things tend to be fairly consistent. There are some differences we notice in sort of the usage patterns of the applications. Actually, Excel and Access tend to stand out as a little bit more, their user base is separated in two very distinct groups. They're the sort of the application or model builders, right? So in Access, they tend to build, the databases and the applications, and then they're the users of these things. And Excel is kind of the same thing. Some people, there's a small number of people who build very complex spreadsheets, and then a lot of people who use them. The other thing about it, Excel also has this little difference where we notice that about 90% of the people who use, 90% of the time Excel is used, it's actually used as a list management tool. It's not used as a spreadsheet. So, interesting things. But generally, most of what we see about one application tends to be true of the other. That used to actually be very different. It used to be a very big difference in how much usage each of the applications got. And Word used to be used by 90% of the Office users, and then you had Excel, and then you had PowerPoint, and then you had Access. And that's actually sort of leveling itself a lot more. Word is still way at the top, but a lot more people use PowerPoint now. PowerPoint has now become a verb. I don't know if you've noticed this, like, can you PowerPoint me something? Or it's kind of cool. Of course, we started with an advantage by using the name Word for the other one, but we're seeing things kind of become a little more uniform. Usage of Office become a lot more uniform. We face, one of the things that we face is trying to understand who our customers are and what they ask for. We, actually probably started being very hardcore about doing this back in Office 4, which was 93, 94, something like that. Before that, we made a lot of assumptions about what our users did, what they wanted, who they were. So a few of the interesting things we do now to sort of learn more and get to know our customers more, I'll explain a few of these here. The first thing, this is my personal favorite, and I think the most valuable one, is we do these what we call IVs, or instrumented versions. And these are versions of the applications that log absolutely everything that a user does as he or she is doing them. What we do is we usually send them out to a few hundred sites, of course, telling them what we're sending them, and we'll log the data for a month or two, and then collect it all back and get it all analyzed and learn all sorts of interesting things from it. It's sort of the most, it's the hardest data that we basically collect about our applications. And usually, it validates a lot of things that we assumed, and then there were some surprises. The first instrumented version, well, when we did the instrumented version of the 97 apps, to our great shock and surprise, we found that 60% of the users or something that were using our versions were actually using the grammar checker, which we never ever expected. We always assumed that the grammar checker, I don't know if you've ever used it. I find it kind of inaccurate. It kept us from we were on the verge of making a decision to take grammar out of our typical setup for the maintenance version for the Office 97A, and saw this data and pretty much realized that would have been a mistake.
That was the old grammar.
What's that?
That was the old.
Yep, that was the one that really sucked.
Yeah.
Yes. Amazingly enough. But anyways, a lot of people used it. Now it's a little hard, it's a little hard because that was actually, I can't remember if this was our first, well, I'm not going to go down this path. I can't remember if that was the first version of the grammar checker we ever shipped, in which case it might have been just a novelty thing. But anyways, the other thing is there used to be this error message that Word would put up, can't find your template when you open a document that the associated template couldn't be found. It was an error message. It was there forever. We had it back in PC Word. We never thought anything about it until we got this IV data back and noticed that 86% of the time that people open documents, they got this stupid error message, which you can do nothing about, which tells you nothing, and which is absolutely worthless because we copy all the data from the template into the document. You don't need the template anymore, right? So, and it was just one of those things where we're just running on autopilot with the blinders, never assumed anything about it. And so we learned all these wonderful things from the IV, and we've, from version to version, actually made them more and more elaborate, where we gather more and more data, and we've learned all sorts of really interesting things from those versions. Let's see. Usability studies. This is another interesting. Have you all seen videotapes of usability studies? This is basically where we we pay users to come in, pay them $75 to come in, and we sort of lock them in a little room with a computer and a list of tasks to do. And there's a little, camera over their shoulder recording their every step, and it just, watches how they go about their work and what they try to do. And usually, we do a lot of usability studies with prototypes for new features and just sort of ideas. And boy, if you ever want to cringe, watch those videotapes. They tend to be rather entertaining, but they're also very, very revealing. You literally cringe. You feel the user's pain, and they actually are very good tools. Usability studies, if they're actually designed properly, which is one of the hard things about usability studies, is designing them properly in such a way that you don't sort of skew the results one way or another. How do you ask the questions? How do you design the test? They're a great way to validate designs and to compare different designs for ease of use. So those are interesting. The other thing we do these days is we do a lot of customer visits. We actually send essentially everyone who works on Office, 2,000 people, out on customer visits every time we start a new version. And it is, before we started doing this, once again, probably a small percentage of the people who worked on the apps, who worked on the product, even knew what our customers did with especially developers and testers who tend to, not worry too much about the customer. I've never seen, how our customers use our tools. So this is another great way of sort of living the pain of our customers and seeing how they, how they use the product. The way we tend to do them is we will go to some customer site, and although this sometimes gets a little uncomfortable for people, we just tell them, you know what, just do your work. We'll watch you. But you learn these incredible things. Like one of the things we quickly learned the first time we did sort of a broad set of a lot of these sound like but the first sort of broad set of customer visits we did is that we noticed that the main way of getting help on Office was to walk down the hallway and ask the expert, ask the person who knew all about Office, right? And that through a lot of sort of turns and grinding of the wheel is basically what inspired the answer wizard, right? This lovely little character, the little clip it thing, which actually the first version of which was just basically an edit item that you could type English questions into, and it would sort of map them to some help topics. That was the inspiration for creating that feature, and actually for all the hate that people have for that feature. I wish I'd set this up. I brought a videotape. Has anyone seen the Conan O'Brien clip it skit? Maybe I can play it at the end. For all the hatred that people have for this, for the little character and asking him questions and stuff like that, we noticed, from the instrumented versions, we know that people use it, on average at least once a week. PSS tracks, the product support people track a lot of the questions and the phone calls they get. After we shipped the first version that had this tool, we noticed that like 20% drop in the sort of how do I questions that were set to PSS. We're assuming it has something to do with it, with the character. It might, with the answer wizard. It might not, but it seems kind of likely that it does. The last thing is what we call advisory councils, or the OAC, the Office Advisory Council. And what that is basically a set of customers that we bring in at the beginning of the design period, the beginning of the design period of a version of Office, and we get them extremely involved in the whole process from start to beginning. Yes. Yeah, and they feel very special for that 1 second they have of one. No, from start to end. And we bring them in. They meet here about 4 times a year. We actually go out to their sites 4 times a year also, and they are involved in everything. They get to see our specs. They get to see builds of the product all the time. They get to provide as much feedback as they want or can, and it's worked pretty well. Actually, what's been the best OAC we've had so far is the one we had for Office 2000, because what we did is we decided to get a bunch of IT administrators and bring them in and get them to focus uniquely on TCO features, on the total cost of ownership features. And all the TCO work we did in Office 2000 comes basically directly from them. They are the ones who sort of had the ideas and gave us the feedback, and it's worked extremely well. And now they kind of feel like they need to deploy our product also because they were so.
What range of applications do these companies cover?
Pardon?
What range of applications do these companies you have in your advisory council cover?
What do you mean the range of applications?
What industries?
Oh, they are all over the map. Like the Office 2000 Advisory Council, we had some. Usually, it's about half the companies are domestic companies in the U.S. and then the other half are international. There was Goldman Sachs. There was a couple investment banks. There was Ford, HP. There was a big rail company in Europe. There were some banks. We try to do is sort of a wide range, but we also, since the focus was very much on IT and administrative tasks, we really wanted huge, people who were responsible for 75,000 desktops or 100,000 desktops and stuff like that. So it was definitely that, a slice of that was skewed towards large organizations. Okay, so this is where it all comes together. This is, you can tell I ripped off this slide from someone because I would never create a slide like that. This is the 3 sort of branches that go into designing a new version of Office. There are there are sort of the customer requirements and input. We have a lot of ways of collecting from customers, what you want us to put in there. There's, this wish list that gets created that you can actually send email to. It gets created stuff gets added to it by PSS people. A lot of direct contact with customers. We get a long list of things that customers ask us for. That's part of it. We also have a lot of, on the other side here, what we call unarticulated needs, and this is the stuff that we learn from customer visits and that we learn from, these things, cognitive walks and contextual inquiry. Those are big words for me, but these are all about us walking through scenarios. So customer says he wants to do X, and spending a lot of time trying to figure out, what the right way to do X. It turns out that a lot of what customers ask you for, this might sound a little arrogant, but is not what they really want. they don't, we've made the mistake in the past of just kind of blindly implementing something, going, God, this doesn't sound right, but everyone's asking us for it. And in a lot of cases, sort of our misgivings tend to be validated because, it turns out that we actually understand a lot more about the product and stuff like that. But it never, but the thing to always remember is that the goal that the customer is laying out, you can't argue with the goal, right? You can only really argue with the method of getting there. So that, that's what a lot of the unarticulated needs, that's what we consider unarticulated needs is sort of things that aren't explained to us by customers, but that they obviously want. And then, of course, there's the technology bets and imperatives, things that, we do for sort of strategic reasons for the company, or, since it takes us about 2 years to ship a major version of Office, we sort of have to look in the future a little bit and take some guesses about what people are going to be doing 2 years down the road. We've made some, that's probably one of the tougher things that we do. We've made some bets on things that haven't panned out, or have been sort of slower to take on. In Office 2000, actually, we made a big bet assuming that people would have a lot of internal web servers, intranet web servers. And that's not taking off as quickly as we thought it would. I mean, it is taking off, but we figured, by the time we'd be done, everyone would have these things and file servers would be on their way out, and that's not really happening. But anyways, other things like Olay and all these different.
Do you ask users that do not use your product, for example, users that use FrameMaker as a word processor, or
yeah, actually, we do. That's we do a lot of sort of focus groups also as a way to get data from users, and what we'll do for focus groups is bring in a certain set of customers that are skewed, somehow in one way or another, sometimes because they use competitor products of ours, and just have discussions with them. They're not very rigid or structured, but we learn a lot from talking to talking to people who use competing products. Part of it is that, again, I'm going to sound arrogant, we don't have that much competition in the core sort of product areas anymore, right? In the word processing world, there aren't that many, the one thing that what we tend to see are, people who use other word processors because they just want something simpler. There are people who do that, right? These are the people who are out there using Notepad or whatever, or WordPad. There are people who do that. But, we don't, there are, Star Office is around, and they have, up until recently when Sun started really giving it away, they had some absolute, very, very small market share, mostly in Germany, actually. Now it's kind of, picking up a little bit. It's a little hard to tell where it's going to go. Sun isn't really pushing the client apps as much as they're making a big deal out of this whole hosted service thing that they call Star Portal, which they just keep on slipping and slipping, so we don't really know what, how much of, we don't really know if they're going to back off on that or not. But it's a little hard to identify the competition these days.
So you talked about sending instrumented versions to
Yep.
customer sites and doing it. These sound like companies. A fair number of people use Office at home. Do you have any way of?
We do. We visit homes also. Hello. No, when we do customer visits, actually, we very intentionally do send people to large orgs. We kind of segment the market into lorgs, which are large orgs, morgs, which are medium orgs, and then what we call SOHO, small office and home office. And so we send people to all those different sort of categories of markets. But the reality is that we actually our market share. If you look at our not our market share, if you look at our sort of revenue share and distributed over these different markets, the large orgs make up 80% of 80% of the money we make. And if you look at our our sort of usage share inside of the different markets, 98% or something in lorgs and something a little lower in morgs. And then when you go down to the small office and home office, it's actually very small. The data shows us that only 13% of the people who have computers use us at home. Yet I will bet you that you could walk into any house and find Office on the computer, right? So, yes.
Since you dominate so much, say in the United States and Europe, how much do you then focus on places like Japan where Office is not there?
Well, actually, we actually have huge share in Japan now also. But
Word processing. What was that competitor in Japan?
Ichitaro, yes. Let's see. We have definitely, Japan is a good example of actually a place that a market that we started focusing on, later than the other markets, and it's been fairly. We've actually have been fairly successful in Japan. Once we started, there was a competitor there at Ichitaro that had a huge share of the market, and once we started, actually, we used to develop the Far East, the Japanese version of Office in Japan, and so it was a very tedious process where, once we were completely done with a version of Office, we would throw the source code at them, and they would, actually do some very extensive modifications to it to make it work in, with Japanese and Chinese and, all the different Asian languages. And, they would ship their version about a year later, a year after we did, and then about a year after that, we would have a new one, and we would throw the source code. Their changes would never make it back in our source code. It was an incredibly inefficient process. And we ended up with, versions of Office over there that were actually fairly low quality. So what we did is we actually just started doing the development for those in the core groups here now, and we ended up with much better versions of it, much better versions for the Far East market, and our share there has gone up quite a bit. Actually, Korea is a place where where there's a very good competitor, although they're in trouble financially, where there's a very good, word processor, and they have a spreadsheet module also that's quite good.
But I just meant.
But in general,
Does that make you?
In general, we don't really know. Again, I'm going to sound arrogant here, but we don't really know where to look for competitors anymore. The competitors these days, there's a perception that what we would lose share to is not going to be another Office suite, another word processor. It's going to be one of these newfangled, web-based. I mean, there's 400 little web-based, mydesktop.com, halfbrain.com, all these things that try to do, a little core of what some module in Office does, but do it all, on the server. Maybe that's where the competition is. That's what we're focusing on more now. Yes?
One question to your previous slide. What is the distinction between specification and integrated specification?
Did I mention I stole that slide from someone?
No, but it's there. So what is an integrated specification?
That actually just refers to, if I understand the slide properly, I think all they're talking about, all this refers to here is is our specs, right? What we do a lot with some of our early specs is we actually show them to customers. We will go out and talk to customers that we've talked to before and say, here, look at this. What do you think about this? It's just sort of the cycle of getting the requirements and the input from the customers and actually saying, okay, I think I know what you're talking about, and we'll write it up in a spec and then show it to customers and ask them for feedback on it. And it's just one thing that we do more and more of is we actually getting customers involved in the design has actually paid off a lot. It's kind of a pain, but.
So these specs are use case descriptions or what?
No, specs are they're complete descriptions of what a feature or change to the product would be, right? So if we added background spell checking to, so when we added background spell checking to Word, for example, we had a document that described exactly what the idea behind the feature was, what it did, it checked spell checking, it spell checked in the background and what the UI would be like, and that's all it is. That is, writing specs is what our program managers do, right? That's their main, the core of their job. So let me go on. So I'm going to fall behind here. So quickly, how we're organized. Now I'm going to switch into sort of how we build the product. Pretty typical, right? We have sort of the core roles. We have developers, testers, program managers, some marketing people who are part of Office. These days, marketing is very centralized, of course, in the company. And then user education people are the ones who write our technical documentation and the help. We also have what I will call other roles. The product planners is probably the more interesting one. The role of the product planners is really to be our link to customers. So they tend to be, a lot of the product planners are actually people, they're actually ex-program managers, and they are the ones who do a lot of the research. Who do a lot of the research that we do. They're the ones who set up the the focus groups and who set up who sort of gather the data from the instrumented versions and are tasked with sort of coming up with the conclusions and studying all the data. It's sort of a role that didn't exist for us 4 years ago or 5 years ago, and has taken on a lot of importance in the past few years. We have designers, the guys who draw the icons, usability specialists who run the usability tests, and their whole thing is making sure that they can do this in a way that's as sort of unbiased as possible, and sort of validate the test, make the test as valid as possible and as unbiased as possible. Product support, localizers. So this is very typical of a dev group, a dev org here. Now here's where we get a little bit different. Just to give you a little bit of history here, back when we did Office 4, Office was basically some brilliant idea by marketing, right? It was a box in which we threw 5 other boxes. There was a Word team. There was an Excel team. We never talked to each other. In fact, we mostly, threw water balloons at each other. And then, we realized that this marketing bundle was actually selling quite well. And we started thinking about how we could, sort of switch our focus a little bit towards, towards the fact that, well, hey, a lot of people use more than one of these applications, and how can we make them work better together, and how can we sort of leverage that? So when we did Office 95, we created a small Office team. It was 6 people or something like that. And their task was to basically do one shared component. The file open, file save directories, the dialogues, I'm sorry, I would call it the dialogue from hell. Actually, the funny story about that shared version of the dialogue is when we ended up shipping it in Office 95, that component was actually bigger than winword2.exe was. And we all looked at this and pointed to it as the failure of Office and of the mode, and how we just laughed about how the shared code would never work. Anyway, so small team, despite the 1.3 megabyte file open dialogue, when we did Office 97, we actually decided to make the Office team even larger. At that point, it was about 25 people. The applications team I'm talking counts of developers. Okay, so 25 developers who were working in the Office team. The application teams were quite large then. Like the Word app team had almost 70 developers. The same, pretty similar numbers with the other with Excel and all the other ones. So the Office teams, this is when we did shared toolbars and shared drawing and a few other things. The model back then was that the Office developers would write the shared code and then throw it over the fence, and the app teams each had sort of small groups of people whose job it was to integrate the feature, the shared code from the Office developers. One of the things we found was that it just didn't work very well to do it that way. Part of what happened is a lot of the shared code got designed in, despite all the best intentions, kind of got designed in a vacuum where not very much consideration to ease of integration was made. It was mostly just, they were designed in such a way that they had, sort of cool and pretty architectures, but not, architectures that were easy for us to plug into, that were actually easy for the applications to use. So in 2000, this last version of Office, that we shipped, we changed that around again. Now, at that point, the Office team was even larger. It got to be about 80 people. It's about the same size now. The app teams were much smaller, about 30 people, for example, in Word. And the big change there was that the teams in Office who were working on shared code were also responsible for integrating the shared code in all the client applications, which was wonderful for the app guys, but it's actually makes being an Office an Office developer quite a difficult job, because you have to deal with 6 or 7 very different code bases that you have to integrate your features into. But believe me, it does force you to make the right decisions about how you design those shared features, because you sort of feel your pain. So, all right. The only other thing worth mentioning here is we also have a new group that we've had for about a year and a half called the Office Sustained Engineering team, and basically what their job is to develop the QFEs. QFEs are sort of hot fix requests that we get from our customers. It turns out that when you have hundreds of millions of people using your product, you get a lot of these, and it quickly came to a point where just satisfying a lot of the requests from our customers was chewing up a huge percentage of our development time. So we decided to create a team who could really focus on that and do that right and not sort of distract the core development groups. Just random numbers to look at. This is about the size of Office. Well, so this is a little outdated. This is, what, 6 months ago, or no, actually 9 months ago. But 416 developers, 654 testers. We sort of have a 3-to-2 tester to developer ratio, or 1.5 to 1. Fewer program managers. Just gives you a ballpark idea of the number of people we're talking about. Isn't this a pretty slide? Just to give you an idea of how our development cycle works. This is kind of this is one of the disappointing things. This is something I would call what we don't do well. This is basically the way we schedule ourselves. When we decide that we're going to do a new version of Office and we're going to start it on such and such date and we're going to end it on such and such date, we basically go, okay, let's see, what's the difference between those two dates? What's a third of that? Okay, at that point we have to be done writing code, right? And then the other 2/3, we're going to fix everything we busted. So I'm going to talk about that in more detail. Yeah?
What's the requirements gathering stuff compared to those?
Pardon?
What's the requirements gathering phase?
I'll talk about that in a second. Well, I'll talk about that now, actually. It's a little difficult because what happens is a lot of that happens while we're still, a lot of that starts very early on, actually, while we're shipping the previous version. And it kind of sort of, gradually becomes more, a bigger, gradually more and more people get involved in it. We can spend, we're already doing, let's see, right now we're working on, Office 10 or whatever you want to call it. We plan to ship it around March or something, or in the spring of next year. We already have a fair number of people who are doing some planning for the version after that. And that's just going to ramp up as we get closer to the... So I don't really know how to give you an exact time frame, but yes?
How much of Office is currently shared?
I don't know how to answer that question exactly. The best way I can do this is to say that the best sort of guess I have at that is actually just through the size of the binaries. Yes. The shared code is about 8 meg, the MSO.dll, right? And then the applications tend to be smaller than that. Word is kind of a big app. It's about at 6 meg. Excel is around there also. So I don't know if that gives you it. The reality is that it's not very much that's shared. We're writing more and more shared code, but still, clearly 90% of Word is Word specific and it's not shared code or anything like that. The main shared stuff we have, just to go over it, we have a bunch of UI stuff, sort of the menus, toolbars, dialog manager, stuff like that. We have a lot of sort of core functions, sort of the what we call kernel junk, but memory management, string management, resource management, all these different things. A lot of utility functions, string comparison functions, and math things, and we have shared drawing, pretty extensive shared drawing code. We have some sort of stuff like the dialog managers and a lot of hyperlink management stuff, but that's basically it. Most of the stuff that makes Word a word processor is in Word. So let's talk about this real quick. The coding phase. Let's look at that for a second. So the first part of that, we split up the coding phase in what we call milestones. And milestones are just sort of big chunks of coding that we set goals for what we want to have done at the end of the milestone, and we set a date for when we want the milestone to be done, and we try to sort of break up all the code, all the features we want to implement into smaller, manageable chunks to sort of keep things from getting out of control too quickly and have points at which we can track our success and track, how we're doing and adjust things if we need to. The first milestone is being C programmers, is milestone 0. Milestone 0 is special. Milestone 0 is the devil's playground. During milestone 0, typically, the program managers are furiously trying to get their specs done and finished. So we developers get to write whatever the heck we want during milestone 0. The intention of milestone 0 is that it's a good time. Milestone 0 is a great time for us to do sort of clean up work on the code and do sort of architectural things that we want to change. But the reality is that it's the wild, wild west. And we cause a lot of damage during milestone 0, and it's one of the things that we sort of are very, have become very conscious of and are trying to figure out what to do with. A lot of good stuff happens during milestone 0, but a lot of bad stuff also. And then we have the sort of normal coding milestones. We can look at what one of those looks like. Typically, we basically split them up into pieces. Write some code, and then what we call integration, which is really just debug the code. So this is actually even worse than it looks, right? Because in here there are debug periods. So we can let's look at the other half here, the stabilization half. So what happens at stabilization? The first point is, at the end of the coding milestones, we have this milestone called code complete, where in theory all the features are implemented. All the code that we know about is written. All the features that we know about, or all the functionality that we know about, is written. It's done. We should be able to ship in a couple weeks now. Reality, again, is not exactly like that. The truth is, you know what? Developers lie. They actually do. We put a lot of emphasis on, sort of pushing people to be done with all their coding when they said they were going to be done with it. And, people sort of, some people stretch the truth a little bit. I wouldn't say that's the majority of what happens, but it happens. The big thing is we forget a lot of stuff. There's a lot of stuff that just doesn't all come together until code complete, and then you look at all these features side by side working together, and you go, well, this doesn't make any sense. We need to fix this. We need to fix that. Some features get added after code complete. We swear up and down that we're not going to do it this time. Every time, there's a few little things that you go, well, boy, that'd be so cheap to do, and it really would make so much sense. And, in a lot of cases, it's the right decision. But there's a lot of things that happen after code complete, despite the sort of theoretical definition of what it is. Pardon?
But is that in the coding stage? Do you actually ask the time estimates from developers? How much time it would take to implement so feature?
Yeah, absolutely. I'll talk about that in a second. So, next, I got to speed up a little bit here, but so going down through the stabilization phase, our first milestone is the first beta, which usually goes out to a few thousand sites. It is mostly sort of an internal exercise in making sure that we get all of our I's dotted and our T's crossed, and then we can actually go from all this source code to actual CDs that people can install. It forces us to get all of our setup stuff done in time. It forces everything to come together. The reality of the beta is that the first beta is that very few people install it, which is unfortunate because that's the only beta that we can actually get feedback from and act on. But very few people install it because, frankly, the products aren't that stable and they know it. So next milestone, ZBR. This is what we call 0 bugs. Of course, it's not 0. It just sounds good that way. ZBR is more about, for us, the thing that makes it an important milestone is that it's about getting current on your whole list of bugs. Right? The goal of ZBR typically will be to have no bugs that are older than 48 hours. So what it basically means is that you can't, have these old, ugly, nasty things that have been lying around for months and just you ignore them and you fix other bugs and you just, keep letting these old things sort of rot away until someone forces you to fix them. That's what ZBR is about. It's hard to understand what the meaning or relevance of ZBR is, except that it's a very easy date for us to try. It's a very easy sort of criteria for us to track, and we have very good, fairly good historical data about how long it takes us to go from ZBR to ship. So it's an important metric for us to be able to calculate. Next thing that happens, beta 2. This one goes out to tens of thousands of sites. That's an important, that's that one people install. They send us all this feedback, and we go, well, we're shipping. What are we going to do with that? We'll take it into consideration. The beta process in a way is very seriously flawed because of that. Next thing that happens is we start doing release candidates. This marks when our first RC, or what we call RC0, marks a very important sort of change in behavior for people. At that point, no code change gets made without being code reviewed, without being triaged by by the group that owns the code, without being triaged by sort of this the central committee who a lot of things need to happen. A lot of bars need to be cleared before code changes get made. And so the whole point of entering RC mode is to sort of start shutting down the products and making as few changes as possible and do everything to keep the stability high and keep us from breaking things and get into this vicious circle where we can't ship. So we do a bunch of RCs and we finally ship. Usually it takes us 6 or 7 RCs. That's pretty typical. So.
Are the proportions correct on your timeline?
Approximately, yeah. Yeah.
And where are you for next year's version?
We are about to do beta 1.
So be sure not to install it.
So how long is that total time period?
Pardon, from when to when? The stabilization period? It varies from project to project, right? Some projects we sort of...
Office 10, for instance?
Nearly a year. Yeah. So, talk about scheduling here. This is the life of an Office developer during milestone 0, or sort of pre-milestone 0 between the two projects. We go through this whole process where we figure out a big, huge list of features. We dole them out to different developers. You do sort of preliminary design work on all the features, and the whole point of that is to mostly be able to schedule them. And the main thing, the most important part that goes on at this point is to actually schedule the features. So we do enough design work to be able to do what we think is an accurate job of scheduling the features, and then we can sort of line them all up and figure out who's way off the end, and then we can shuffle things around, we can balance the schedules, we can move things from person to person. The one thing to say about this is the scheduling is probably the most difficult thing, I think, that most developers do. They think writing code is hard. Scheduling accurately is a black art. People just, it's very, new developer coming in, you give him a feature to schedule, I will guarantee you that he's going to schedule it at, probably less than 25% of the time it's really going to take him to do it. And experience is a huge advantage. You learn a lot from scheduling. But the thing that's hard is that part of what we do with schedules is we ask people to stick to them. So you want to be able to schedule accurately. I'm sorry. Yes?
What you call coding before, or do you really mean design as you had it on the previous slide?
What I mean is just sort of overall design. Well, what do you mean? No code is written, right? What I mean by design is just figure out how you're going to implement something.
So is this part of the specification of building the architecture, or what are the features? What is it design?
Oh, I'm sorry. Yes. Okay, I use a confusing word there. Designing, I should say designing the features, right? Designing the implementation of the features, so the architecture of the features. What are your data structures? What are your algorithms? How are you going to plug this in? It's not about, what the feature does or what the UI looks like or anything like that. It's just about sort of doing the, it's the first step in figuring out how you're going to write the code for developers. Okay? So keep going here. We're not even at the interesting part yet. More slides. Okay, so now during the milestone, of course, this is fairly straightforward. This is where you're writing the code. The implementation starts. Life is a little different for the shared developers versus the app developers, mostly because the shared developers have to be able to build all the applications, and they're changing things all over the place, and life's a little more complicated for them. Typically, application developers only build their own application plus the shared code. In a typical day, write code and fix bugs. That's pretty typical. Checking into the source control system is something that we try to get people to do as often as possible. It's actually a big challenge that we have because it's very difficult to do that. I don't know if a bunch of you might have seen Mark Wachowski's presentation about how this was such an impossibility in NT. Our life isn't that bad, but it's still a huge barrier to us. We still use the old source control system.
You mean plans upgrade source?
Yeah, after Office 10. So when developers check in, we make them we force them to do a bunch of things. We force them to sort of sync up their projects to a known good state, and then run these check-in tests, which are these automated tests on each application. They're sort of designed to be very quick. They take 5 minutes or less to run on each app. But the idea is that they don't, make sure they haven't broken something that's going to block every other developer from doing their work. It's got nothing to do with figuring out whether they their feature, that their code that they were just writing actually works, just to make sure they don't block anyone. And we also would like to force developers to profile and do some performance analysis on their stuff before they check it in. That's a thing that we just have a very hard time getting people to do consistently, and we pay for it. And then all developers do full builds overnight. It takes, just to give you an idea on these sort of newfangled 800 megahertz, 256 meg machines with ultra-fast hard drives that we have now, it takes about 10 or 11 hours to build all of Office, ship and debug, and run the quick tests or check-in tests on them. So it's actually quite a bit. During the debug period, this is the long red tail. Life is all, you live with the bug list. It's all about, we use this tool called RAID, which is a big database of bugs. The testers enter the bugs in RAID, and you spend your day looking at your bugs and trying to fix them. We tend to be very sort of goal-driven. A lot of the groups use weekly goals of, either overall count for the group or bug age or priority. And this is sort of the part of the project that gets to be mind-numbing. And unfortunately, it's the long part of the project. So there are a lot of reasons why we would want to do this better. Quick word about the code. All the apps are written in either C or C++. Excel and Word are the only C apps. Everything else is in C++ these days. Basically, Excel and Word being the old apps, the other apps being more recently written. Just to give you an idea of how much code we're talking about, here is Office 2000 versus Office 97. It's kind of interesting to look at this. These are lines of code, by the way. Office, you can see in 2000 grew a ton. Word actually grew a lot. Excel, actually, this is kind of a funny thing. A lot of things, there's some big things that went away in Excel. There's some internal things that they had for reading old versions of files. All their file converters and stuff were internal before, so those things went away and they came in. So they don't look, it doesn't look like Excel grew that much, but all these apps grew quite a bit during 2000. Another way to look at sort of the sheer volume of change, if you just look at Word in Office 2000, 25,000 check-ins, 145 different developers touched the code, even though the core Word team in 2000 was only about 30 people. Touched almost 1 million lines of code in the application in one project. Huge amount of churn. And it's, added 70% to the size of the code. So a lot of, it's not like we touch just a few little things and then break the world. We actually touch a lot. Now, you could argue that the reason we touch a lot of things has to do with our fairly, I wouldn't say Word in particular has the cleanest architecture in the world. And it probably has a lot to do with that, with the lack of encapsulation of things and a lot of lack of modularity. I mean, there's a lot of there's a lot of things that are scattered all over the code, and a lot of code needs to be changed. Yeah.
So what explains this locality where 80% of the changes are by less than a quarter of the programmers?
Basically what that is that's the core, the guys who spend their days working in Word. They're the app developers, and then the other set of people are usually the shared feature team developers who are the ones who do most of their work in the shared code and then write a little bit of code or as little code as possible to actually integrate their shared code into the applications. Does that make sense?
Yeah. Well, the other possibility was that a quarter of the people were working on the new features, which was most of the changes. But it sounds like it's based on the keenness of the people and not the keenness. The other thing we know is that if you just look now, if you take that, if you took that 20% of the developers and then looked at who's making, how the distribution is there, you end up noticing that there's a huge difference between very productive developers and not very productive developers. It's very common to see developers who can consistently, if you're going to use, lines of code as any kind of a metric of anything, that's, what's that? Which you shouldn't. Well, especially when you start measuring it, you start skewing the results, right? But we don't tell anyone about this. So, but there are definitely developers who consistently seem to crank out more code than anyone else, and some of them get into a lot of trouble doing it, and some of them are just they can actually crank out a ton of code and actually have very few bugs, and so there's a big range even in sort of the productivity of developers if you're going to measure it that way.
How do you measure these?
No, how do you document them? Do you keep track of them so that later you know what they
The only way they are kept, they're automatic. So all of the changes are kept are kept in these diff logs that are generated by the source control system. So all the the only granularity you get is when someone checks in, all of the changes are sort of logged over, logged into these files that you can go look at, and it's actually extremely useful to be able to look at them and see why people make changes. But part of the thing about checking in, about getting people to check in often, part of the usefulness of getting people to check in often is that if they don't, you end up with these huge changes to files. With if someone was checking in a month's worth of work, well, it doesn't help you that much to go find that in the diff log and see, yep, sure enough, he checked in this change on this date along with 400 other lines of code that were changed, and the comment in the in the diff log says new feature. You learn nothing, right? But if people can check in more often, they usually will include bug numbers and stuff like that. So, but that's the only way we log them.
So it means that you don't change your specifications, which you had at the beginning. You just change the code.
Yeah. Yes. The specifications tend to get wildly out of date. They do. Okay, so let's talk about what we do well. I'm so behind here. You guys aren't doing anything at like 7, are you? Okay, things that we do well. Just very quickly, these are the things that we've kind of learned about over the, doing a few versions of this product well, that I think are actually worth pointing out because they have huge value. One of the things that we are very conscious of these days is defining a very, very clear vision for the product. It turns out that when you have 2,000 people working on something, you can't, unless you give them sort of, I don't want to say simple goals, but very few goals, nothing works, right? So one of the first things that we try very, very hard to do when we do a new version of Office is to define a very clear vision for the product. Usually, it'll be it won't be that clear because it'll be like sort of a 5-part vision or 6-part vision. But we really force ourselves to figure out sort of these buckets of things, these areas that we want to address, and make sure that everything we do falls in one of those areas, and that everyone understands the importance of those areas and why we're doing them and what we're doing. It has actually fairly, not only does it sort of help make a ton of decisions about, what features you're going to do and what features you're not going to do, a lot of trade-offs between features. It also turns out that, the shotgun approach at adding features to these applications is absolutely useless, because what happens is you end up with 200 new features, and marketing will go off and talk about 3 of them, and no one ever hears about the other 997. Some people might stumble across them, but there's, the applications, unfortunately, have, are at this point have so much stuff in them that it's very hard for us to do new things and have people notice them on their own. So vision. Setup from day one is just another thing where it used to be, there are a lot of groups that still do this, where setup is kind of an afterthought. You write the code, then you look at it and you go, oh crap, somehow this has to get off the CD and onto the user's hard disk. These days we actually, setup for us is sort of a first class component. Most of the developers actually, part of your build process is it actually creates a setup image and then installs it onto your machine. And mostly that's just, for one thing, it's because there's a lot involved in installing Office these days. We upgrade system components and stuff like that, which boo, but we still do it. But anyways, so this helps us a lot. It allows people to actually dog food the product from day one. Teams organized by feature areas, not apps. This is just, this is the big. We tend to try to focus in a group. So if I'm in the sort of Office development group, we break those groups up into sort of small teams that are focused on specific areas. So there's the UI team, for example. And what we try to do as much as possible is make the UI team, whether it's in Office or it's in Word or something, be responsible for UI across the board in the product. Even if they're, we have cases of groups that are in the application, teams that are in the application groups that are sort of responsible for at least at least sort of ensuring consistency across all the applications. For example, all of the Unicode work that we did back in 2000 and all of this sort of integrating, these days we have these single worldwide exes. The same executable actually is used, for whether it's for the Japanese version or an Arabic version that goes right to left or U.S. version. A lot of that work was all coordinated out of people in the Word team, even though it was done in all the applications. So, this is again about having as few people as possible sort of focusing on the task and sort of empowering them to get things done across all the products. Unified test harness. This is just, we now have a unified way of actually driving the applications to do tests, which turns out to be very useful. Automated testing is becoming an incredibly important part of our testing strategy. You just can't do it all by hand anymore. So writing solid automated tests is incredibly useful, and having a consistent way to do it across the applications makes a lot of sense because, at the very least, it lets you write cross-app testing scenarios. One of the interesting things about this is that the hooks for testing actually ship in our applications.
Against what do you test?
We mostly use some internal tools that are written that our testing groups have written. So they have test case management tools that sort of keep track of all of the automated tests and all the testing we do, and then how many Tom knows about this?
The automated tests usually use OLE automation to drive the application.
Yeah, actually, we don't. More and more of our tests that we use these days have special, because what happens is by using OLE automation to drive the applications, what you end up testing is the object model of the applications, which doesn't really necessarily get, since our applications, a lot of our applications predate OLE automation, the object models tend to be kind of tacked on to the side, right? So since a lot of our users use the applications through the UI, not through VBA, we want to make sure that the automated testing scenarios actually exercise the UI a lot also. So a lot of the hooks for automated tests are actually hooks into sort of UI elements, right? It's not like send keys. They don't generate key presses, but they will generate, they will sort of simulate key presses on buttons and on toolbar buttons and dialog elements and stuff like that.
So these are not tests against your specifications?
No. I wonder what you do. Yeah. It's actually, if you had to, one of the observations, at least about the way we do, I think we do development compared to what sort of the software engineering things that get taught a lot, is that the boundary from specifications to code is very, very loose. We don't have very formalized specification processes, and it suffers because of that. What it does is, what's good is that it does give us a lot of flexibility, and it tends to be a little more freeform. But we've never really sort of gotten into this mode of having very formalized specification documents.
Do the testers start writing their tests before the code's written or after the code's written?
They tend to write sort of test plan documents before the code's written based on some of the stuff in the specs. Hey, well, obviously we're going to have to test this, test this, test this, test this. But until the code shows up, they're not writing automated tests.
So that's why I asked, you see, because the problem is that you may test against
Misunderstanding.
Yes.
Right.
Yes, absolutely.
That's why I asked whether you have a way to test against specifications that should be there prior to code.
No, I certainly will not disagree with your point. And the answer to your question, though, is no. We don't have a way of doing that. So rigorous spec inspections. This is just one of the things we've noticed from doing analysis on the bugs that we end up fixing is that a huge number, like over 40% of the bugs, if you picked at random 100 bugs in the bug list after the project is done, over 40% of them, you could classify them as being spec issues. Okay, so you're going to love this, yeah. But no, but yeah. Basically they have to do with something that wasn't mentioned in the spec, some issue that wasn't dealt with in the spec that should have been dealt with in the spec, some misinterpretation of the spec, all sorts of things. They tend to be cases that weren't handled by this, that weren't, that need some kind of decision that you would expect to be in the spec that didn't actually get made, and since they weren't in the spec, the developer didn't think about them because we're not too smart. And so this is a big area for improvement for us. And so part of what we did is we started being much more rigorous about looking at specs and inspecting them line by line, by item, before we even start implementation on them. It's an incredibly tedious process, but we find a lot of holes in specs by doing that. And the more stuff we catch up front, the better off we are.
Have the number of spec bugs observably gone down?
What's that?
Have the number of spec bugs observably gone down since you started doing that?
I don't know because we don't. We've never gone off and looked at the data before we really started doing inspections, and we haven't been doing inspections long enough to be able to really. But clearly, we just kind of assume because heck, we do inspections and we find tons of things that we know would have resulted in bugs. We just kind of assume that it makes things better, but we have no, we've never done the study to tell how much of a difference it's had. Yes?
When you spoke before about spec and you mentioned that you have this freedom you want not to get destroyed, and you spoke about formalization. My guess is that you don't have the right language for writing your specifications. No, I'm serious about this. It's a problem not only you. So what I want to say is that there is a way to write your specifications in a rigorous way, not going to the level of coding, which allows you to keep track of a relation between spec and code.
That to us is a huge. I just think I've always thought it's kind of funny actually that we've never even approached even trying any of this stuff. We've always just kind of assumed that the system we have works better than anyone else's system. There's the arrogance again. And that we can't do that much about it. But I think it would be actually incredibly interesting for us to try to do something like that. With just try it as an experiment in for one small piece of the product or something like that, and see how.
You'll get me excited because you spoke about all this error correcting, and by this that the relation to the spec is completely lost.
Yeah.
Now, if you have specs which can help you implement this, you would gain a lot of time in error correcting because you would correct probably at higher levels, not
yeah. Yeah. No, I can't argue with that. But the program managers, they're creative people. You don't want to get. No, I'm sorry. Did I say I was falling behind? Knowledge management is just a big issue with, you have this many people, there's so much information getting generated and flowing around that, unless you find good ways of getting the information to people, it's almost hopeless. You can never find what you're looking for. We now just use the big sort of centralized website where you can get the links to just about anything, to the databases, to the schedules. We use an integrated schedule that actually is integrated with our bug list so that you can map bug items to schedules. Our tools are actually starting to work rather well together. But it's made a big, just having all this information accessible quickly has been a very important thing for all of us. So talk about things we do pretty well. We now have a big single, you have to remember that Office started out as a bunch of different apps, a bunch of different groups with their own cultures doing everything differently. Here we are a mere 8 years after starting that, and we finally have all the builds building under one, all the applications building under one big build script, which has been, once you get through the pain of making sure that everyone's using the same versions of the compiler and of the, of make and of the resource compiler and of the type-lib compiler and blah, 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 blah. Once you finally get all that together, the efficiency becomes incredibly obvious, right? So we have this one build system that we call OHome. It's a giant script file written in Perl, and it does all these incredible things. It does, automatically runs tests, runs builds, does, tags, syncs, backups, all this stuff. And it's a no-brainer to actually build everything, whereas it used to be sort of a black art to get all the different applications to build. Yes?
You say the same version of the compiler. What are you doing for Arcadia?
La 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 la. Nothing yet. The extent of our involvement or sort of our push towards 64-bit has been to have
2 people who've been working on just getting the app, getting rid of the error messages when they compile in 64-bit mode. There isn't, no one is seeing an immediate, or is forecasting an immediate demand for desktop applications on 64-bit systems. You got to figure it's going to happen at some point. But right now we're kind of making the assumption that 32-bit is our world for the next, at least for the next version of Office.
Which Office apps were ever on other than IE86?
Excel and Word.
Were compiled
for Alpha. Yeah. And that's it.
The Macintosh platform fit into this pool.
It doesn't. There was a point in time at which there was a core Office team that did both the Mac version and the Windows version. We all hated life extremely strongly because it turns out that multi-platform or cross-platform development is really hard. Which is why I laugh about all these articles about how clearly once they split us off, we're going to take 6 developers and go do the Linux version. Oh yeah. Even if we wanted to. Back when we did the Office 4 versions of the applications, we actually had the same core code for both the Mac version and the Windows version. It basically took us a year to do the Mac version from the point the Windows version was done. And that is by even keeping both the Mac build and the Windows build building all the time and sort of basically running all the time. The reality of it is that the Mac version was always going to get treated as sort of a second-class citizen by us because the tools for debugging on Windows were better. We all viewed Windows as a bigger market. Of course, it is. We were all used to writing Windows code. The way we did the Mac version was by having this crazy layer that mapped Windows calls to Mac calls, and what do you end up with? You end up with a Windows app on a Mac. It looks like a Windows app. It runs like it feels like a Windows app. We shipped it. People hated it. So these days we have a different group that does Mac versions. Different, the source code is forked. It's gone forever. And what's that?
Is there any sharing at the specification?
No, because or very little, because one of the things we've realized is that the markets are actually quite different as far as sort of users go. I mean, we for better or for worse, have sort of focused a lot on large orgs and stuff like that in the past couple of versions, and the Mac, completely the opposite end of the spectrum, right? It tends to be the home users and small offices, and so they've tended to do features that are much more very end user focused or whereas we tended to do some things that are more geared towards working well in large groups of people. So single unified build system, cool. Regular complete builds. We have a big giant build lab like the NT guys do. Well, they have a lot now. We have just still one big giant one. Where every day, everything, in theory, what we would like to do is every day, the big giant build lab would actually sync up all the source code, do builds of everything, run automated tests. We actually do this. The in theory part has to do with how often we do it. We would love to do it every day, but the main thing that this does is that we do in the build lab is we build all the applications, we run the check-in tests on them, which in theory should pass because every developer's check-in had to pass the check-in test before they checked in. Sometimes developers lie. And then we run a whole set of build verification tests on those builds. Now, that's actually a very extensive set of tests. It covers, we run something like 2,000 or 2,100 individual tests. It covers almost 20% of the, when you do code coverage analysis on it, at least on lines of code, it covers almost 30% of the code, which is a lot considering how much code is, sort of error condition code and stuff like that. So the theory is that, once we've sort of passed all these BVTs and we've fixed any problem in the BVTs, we can checkpoint the builds, and that gives everyone sort of a known good state that they can sync up to and do their work from. Now, reality is that it's very hard for us to crank through these very quickly because, BVTs get broken a lot, builds get broken a lot. So much churn actually happens in the code base that it's very regular that people check in conflicting changes, and it's a little bit of a vicious cycle because the less often we can do these builds, what happens while these builds are going on is that the source projects are locked. You can't check into them, right? So since they stay locked for a fairly long amount of time, it becomes harder for people to check in. So they pile up more changes, right? And then when the project opens, you get more crap that gets checked in, which breaks things even more, so the projects stay locked longer. So it's a very difficult, it's a very difficult cycle to get out of. And there's many, many reasons why it's difficult, why we have a hard time getting quick turnaround on these builds. The other thing I will point out is that these days we like to log just about everything that goes on in a developer's life. We're kind of doing the Big Brother thing a little bit too much, maybe, but we log like these. One of the things we do with these unified build scripts is that we log sort of every build error that a developer has, and this is not, this has nothing to do with, it's review time, easy enough. Let's see how many build errors. Oh God, the guy forgets semicolons all the time. It's not that. It's just that a lot of the build problems we see, actually, unfortunately, have to do with, not a change in the code that someone made, but some sort of assumption about what the, what the state of their machine is, which is very, very, very problematic for us. Problems that, problem with the wrong version of the system component being installed, or some file in the project getting ghosted, or something not getting moved to the right place. And the build process itself is so complicated, unfortunately, that things go wrong. And by logging a lot of the things that go wrong, we quickly notice what's affecting a lot of people, and we spend a lot of time trying to fix those things. But obviously, it's I would categorize the build, sort of the stability of our builds is a big problem that we have. Actually, the predictability and repeatability of builds on a developer's build machine is very difficult to get right. The other interesting things that we log all the asserts that fire. They all get logged to some big central database, so you can quickly look at what are the top asserts that testers, developers, people are running into this week. They all have unique tags that are automatically generated, and a lot of sort of interesting things you can do with that. Like our assert dialogues these days, if there's a bug corresponding to the assert that you just hit, it'll automatically show up in the assert dialog. Keeps testers from entering a lot of duplicate bugs. This is actually a feature we're going to ship. What this is it's crash logging. When an application crashes, we have these exception handlers that do a bunch of work to sort of collect up a stack trace, collect up some global data, collect up, per thread, of course, collect up a bunch of different information, compress it up, and send it up to a server. And all this stuff gets, again, gets stored on the server and gets sort of bucketized using, by looking at the IP and the stack trace, you can, and comparing it with the version of the product, you can come up with, you can use a PDB to find out sort of some invariant place in the code, and you can bucket these things across build versions and all. You can do a lot of interesting analysis and find out where people are crashing. So this, as an internal thing, it's interesting because we really want to make sure that we keep, that we get sort of the top bugs out of the code quickly so that people don't run into the same problems all the time and get slowed down by them. As an external thing, as a feature to ship, it's actually extremely interesting because we have a nagging suspicion that, that a huge percentage of the incidences of people crashing are actually caused by a relatively small number of bugs. The graph probably looks like this. I'm sure there are a lot of different crashes, but there are probably very few crashes that account for 80% of the incidents. We don't know what those crashes are. Right? The problem with crashes is that, person X calls PSS and says, damn you, my app crashed, you lost my data. And you can't tell anything from it. There tend to be very expensive PSS calls because they last a long time. It's very difficult for them to diagnose these things. So the goal with this, of course, is that we can easily figure out what these crashing bugs are. And we have a whole mechanism for posting back information to users about, hey, we have fixed your bug. Here's a link to a patch. Hey, this is a problem with your video driver. That's going to be the standard excuse, of course. Go see ATI's site. But we actually have pretty high hopes for this feature. Actually, we have a lot of infrastructure, sort of server-side infrastructure built around this, and there's a bunch of other groups who are using it now. Like actually the Mars shell went out in beta with this stuff, and so we're collecting all their data live, and it looks exactly like what we'd expect it to look like. Perfect curve like that. They could go off, if they went off and fixed 3 crashing bugs, they would take care of probably 50% of the sort of instances of crashes that people see. More stuff. We actually have some pretty good internal performance tools that people use. We have a very powerful profiling tool called IceCap that actually comes from you guys, right? Part of the problem is I don't know if it's intimidating to people or if it's confusing to people or what, but we've had a very hard time in the past getting people to consistently profile their code. One of the things we did is we have a small performance team inside Office who do 2 things. They actually write perf tools, they write and evangelize perf tools, and they go around and hit people with hammers. And so some of the tools, they've actually written some fairly lightweight profiling tools that are incredibly easy for people to use. And that's actually, sort of that and the evangelism has actually driven up the amount of performance work that gets done on our, that gets done by people, before checking in. It doesn't mean, this is actually, again, I'll have this in the next slide or something about things we don't do well. We go through huge performance roller coasters. If you look at our performance, if you look at sort of benchmark numbers, right now, or just probably like a month ago, at Code Complete is sort of the prime thing. Everything is 3 times slower, right? Performance seems to be an afterthought. We don't know how we can, we struggle with trying to keep that from happening, but it's totally a break it now, fix it later scenario. And it's, of course, much harder to fix it later than to fix it to not introduce the problem in the first place. Our coding and scheduling methodologies, we actually have a pretty good feel now for how long a project should take, given how much stuff we're going to be doing. It doesn't mean that we're happy with the ratio of how much time we spend coding to how much time we spend fixing bugs, but we actually have fairly predicted. I'm not going to say our schedules are predictable because we slip all the time, but we are reasonably accurate. How's that? Yes.
So, what is the nature of your performance problems? Is there the same sort of locality, certain types of
let's see. It's very, very, very rare that the performance problems are caused by some, oh, geez, here's an n-squared algorithm, right? Wouldn't that be fun? The reality of it is that when you look at, the real root problem with performance more often than not tends to be how much stuff gets read off the disk. How many pages of code are getting swapped in? How many DLLs get loaded at boot? How many, that's a big chunk of things. And then when you're talking about, a lot of the sort of network-based things we do, talking to mail servers, talking to HTTP servers, then it's all about how many RPC calls you're making, how many times you're talking to the server to do a specific thing. So there are some very, some obvious areas like that. It's part of what's unfortunate about it is that we push people and push people and push people to use profilers, but the profilers actually rarely reveal the data that's real, that causes the real problems, right? When you're talking about pages pages coming in from the disk, it's hard to see that when you're looking at how much time it's taking to execute certain pieces of code. You look at page profiling, you can tell a lot more from stuff like that. But, frankly, most of our performance problems, I think, are just caused by people not being educated enough, right? It seems like we just spend our days, trying to explain to people that you don't want to bring in any more DLLs at boot. You don't want to, read the registry more than the 1,500 times that we already do at boot. You don't want to do this. You don't want to do that. Yet people make the mistakes all the time, and then we go fix them. And but it really is a combination of things. Part of the problem is it's also with external components that we use. Very often it's difficult for us to be on the same wavelength as far. This is me blaming external groups, but it's very hard for us to be on the same wavelength about what we expect performance to be. Very often we take external components to replace things that we used to do ourselves, and you sort of get a big penalty, a big performance penalty as part of it, and then we. So this just is another example of a tool that we use now. These days, when you check in code, part of what you do is you have to fill in this form, and you fill in just a bunch of information about what you're checking in, what the files are, what you're checking, what the new features or what the bug fixes are, or, descriptions of the problems if it's a bug fix and all this stuff. And this actually initiates a whole workflow process that gets used by testing. That basically gets used by the build through the whole chain of building the application, getting it released to testing, getting the tester to actually run the fixes, and then it gets assigned back to the developers. And there's a whole workflow that goes along with this that actually makes it fairly, gives us a fairly good way of actually sort of tracking everything that goes on and making sure that we don't have sort of check-ins that happen and then just go off in the ether and never get tested. And it's a very good way. Part of what this tool does is you can sort of subscribe to certain types of check-ins, and you just get mail. You get flooded with email, about all these check-ins that happen. It's a great way to keep up with what's going on. I mean, one of the problems is, when 400 developers working on a product, is that you can't keep up with everything they're doing. You can't keep up with the changes in the product. So having all this information pushed at you, as you want it, is actually really a very useful thing. This is just more stuff from the check-in tool. This is kind of the workflow aspects of it. Okay, things we're not good at. Maximizing coding time. We've talked about this. The more robust builds and tests. This is the same thing. That when we get builds that are broken or checking tests that don't run, it's actually fairly disastrous. You can easily end up with 400 developers going, uh-oh, and it happens way, way too often. There's a general perception that that we are much less efficient as developers than we were probably 5 or 6 years ago. It's a little hard to come up with data that shows that. You can if you try to look at how much code gets checked in or how much over the years or anything like that, per developer, it's very I've never seen data that actually validates it, but I sure feel like it, and every developer on the planet seems to feel like it. So there's definitely, as things have gotten more complicated, as we've taken on more stuff, there's definitely a perception that our efficiency has gone down as developers. This is, build the break and resolution, turnaround, timeliness is kind of the same issue. Getting people to fix problems when they show up is difficult. How do we reduce bug fixing time? This is where, this is obviously the key to actually one big key to not spending 75% of our time fixing bugs at the end of the project is to not introduce the bugs in the first place. Things are 10 times more expensive to fix, after they've been checked in than if we caught them before checking in. So, the amazing thing is we've done very little, I think, in the past 10 years that has made that any easier. Finding bugs before you check in. What are the big radical advances we've had? Asserts? I think that's the last one, right? At least the last one that we use. There's a lot of tools. There are a lot of tools that have been around for a while. I mean, bounds checker's been around for a while. It's actually a very good tool, except that, it seems like every one of those tools sort of tends to get overwhelmed by the sheer size of our code and some of the things we do. We've never been able to use bounds checker, actually, except up until maybe a year ago, and that was after a year of one of our developers basically working with the bounds checker developers nonstop to fix all the problems. Prefix is another example of this tool. The problem with prefix right now is that it's too heavyweight for us to run on developer machines before we check in. There are a whole bunch of other, there's static analysis tools that have been around forever that are mildly interesting. They're usually not worth running on everyone's machine, but
the common wisdom is that the most bang for the buck in this area is simply to do code inspection.
Do code reviews.
Yeah.
Yeah.
Have you thought about trying to introduce that?
Yeah. In fact, we've had many heated discussions about code reviews. We don't consistently, let's see, different groups, this is one of those things that really different groups inside Office have different philosophies on. Some, at one end, there are groups who basically review just about every line of code that gets checked in, and then there are many groups who do very few code reviews. Most of the groups tend to be somewhere in the middle where you sort of choose to either have your code, if you think you could use a code review on your code, and what developer thinks that, you will get your code reviewed by people. We don't, frankly, there's a perception of code reviews being an incredible time inefficiency. And I think partly that's because we're not good at doing them. Frankly, my experience with code reviews is that you sit there and you argue about proper Hungarian usage half of the time, right? And it doesn't feel like an incredibly productive thing, but good code reviews, when you go through a good code review, you see the value of them. It's just very hard to determine. I'm not sure I'm convinced that if we code reviewed every line of code that got checked in, we would end up being more efficient as a development organization, because code reviews take time. Maybe someone knows how to do them extremely well.
There's an indirect effect that is very important. It's not the code review per se, perhaps.
It's preparing for it.
Preparing for it. Okay, I'm writing this code. I'm going to have 5 people look at it. Damn it, I don't want to look like a fool.
Yes. Unfortunately, you actually have to follow up with a code review after, because otherwise people pick up on the trick pretty quick, on the ruse pretty quickly. No, it's a good point. Yes.
But there is one more thing about this, namely through code review. I don't want to diminish it, but through code review, you will have a hard time to find real specification bugs.
Absolutely.
Because those you find only at higher level.
Absolutely. That's definitely true. Yes.
And if the program is right, or when there's a build failure, that's when it's
great time to do code reviews. You're right. You're right. Right. I won't argue with the code review thing. We sort of have a funny. It's almost a culture thing, a bad culture thing that we have. That this sort of reluctance to doing code reviews, and I think it dates back to a long, long time ago, and it's just kind of, permeated sort of everyone's opinion of them. But we do know, we do, when we get into sort of release candidate mode and we actually triage all the bugs, part of what we do is we actually do code reviews on all the changes that happen. And we know it's actually useful. We find all sorts of problems, right? So,
Who does the code review? Are these the programmers who wrote the code or other people?
Other people. So you always get someone else to go review your code, basically. Reducing the number of sort of a couple other things here about improving the check-in code quality. So tools, I'm a huge fan of the concept of tools that we can get developers to run before they check in. If they're lightweight and they run quickly and they can find bugs, every bug they find, I think, is a huge win. We don't have enough of them. Better developer discipline. This is just smarter people. I don't know. One of the interesting things about sort of check-in tests is that right now all the check-in tests are good for is sort of validating the overall state of the applications. They're not targeted at all towards the changes, towards the code that you changed, right? So there's some talk or experiments going on with sort of having some system for targeting check-in tests where you sort of log, you have your big mass of automated tests in a database, and part of the information you keep along with each test is what pieces of the binary it covers as it's running. And then you can do an analysis of, your binary built with your changes compared to the sort of stock binary, see what you've actually changed and target tests at those. It seems like an interesting idea. I haven't done it. There's some people working on it, definitely.
Just a refinement on that idea, which is before the guy changes the code, do that analysis. Because if the analysis says you're going to have to run yay many tests if you touch that in the code, the developer might
get a little scared. That's a good point. No, that's a good point. Finally, there's the whole staging and sub-projects thing, and that's the core of basically Mark's presentation about a whole system for actually sort of making changes more gradual instead of introducing massive numbers of changes. Right now, we lock the projects when we do things like betas, and things start backing up behind them. At the end of the last milestone, we locked the project for, for a reasonably long amount of time, actually, to just cycle through a build and end up with what we thought was a very solid build at the end of the milestone. And you know what? 2,200 different check-ins sort of backed up behind that lock.
How long was that lock held?
What's that?
How long was that lock held?
It was a week and a half, 2 weeks. So, guess what? You make this great stable build, and then you open the projects and just drop a big bomb in there. So, some way of keeping, this huge influx of stuff from entering the projects would make a big difference. Spec issue bugs. Just some other things, better way of prioritizing bugs. No secret, we don't fix every bug in the product. We don't fix every bug that we find. We do get into a mode, especially towards the end, where we look at the bugs that we have and we choose not to fix some of them. The problem is that it used to be fairly easy for us to have a gut instinct for what was important and what isn't. When you have 100 million users, a bug that affects 0.01% of the people of your users turns out to screw 10,000 people. Actually, I don't know if my math was right there, but so you have you can no longer it's very hard to make those judgment calls about what's important and what's not important, and the result of that is that we end up making calls more in the name of not destabilize. Since we're doing most of this at the end of the project, more not destabilizing things more than in the name of what's important and what isn't. It's a noble, certainly not causing us instability. Is sort of keeping the project stable and actually getting them to a point where they converge to something shippable is an important thing to do. But I think we've very much sort of those decisions are so difficult for us to make these days, and we screw them up, right? We don't fit. We have bugs that come up that we choose not to fix that turn around and bite us as in the form of a QFE or something like that. And you look at them and you go, God, there are 20 other ones like that we chose not to fix that might come back. And it's it's one of the frustrating and difficult things.
How many of the pushed bugs ever get fixed?
Pardon?
How many of those pushed bugs ever get fixed? We tend to spread them out. They get moved over to the bug list for the next project, and they tend to get fixed gradually over. I wish I had that number. I don't know, because part of what we do is we categorize. When bugs get quote unquote won't fix, they go into one of two buckets to start off with, which is some of them we postpone, saying, oh God, this is a bad one. I really want to fix it, but I don't want to fix it now because it's too risky. And then the other ones that we go, this is just stupid. Right? No one's going to run into this. So it'd be I'm sure that analysis has been done with those. We have those numbers. I'm not sure. I don't have them off the top of my head. Yes.
Since Office has pieces of the code base that are at different ages, like you said, some are in C and some in C++. Is there any data from over the years that says that all of these software engineering techniques like modularization and encapsulation actually are helping, or is it just is it come down to who's better programmers? The most predictable metric we have is how much code do you have. There's no evidence. There's no evidence that we've seen from if you compare. PowerPoint's an interesting app because it was rewritten a few versions ago from scratch. It's probably the most quote-unquote modern app that we have, using the sort of most modern, and it's probably the cleanest app in the sense that it's it's gone through the fewest number of revs, but it's about the same size as Access, which is a much older app, and bug rates, bug counts, any kind of metric we can come up with, how long it takes them to be done, are very similar. There's no evidence that
there's no evidence. Now, on the other hand, this isn't really an exhaustive study, right? We just have these two things we can compare, and it might be that the PowerPoint developers are just really lame, right? But there's no evidence of that.
If the claims are valid that people have made for those techniques, you would think that it's such a big organization, you would see
that you would see some gains.
Choice of language doesn't guarantee that those techniques are used. C++ doesn't outlaw any technique.
No, but the thing is,
right. That's what I meant, not necessarily the language, but whether or not.
No, but definitely, if you go compare, if you look at the sort of architecture and how the code's organized and all that in PowerPoint, and you compare it with Access, those are the two most comparable ones I can come up with. Clearly, Access is much less modular, much less clean, call it what you want, than PowerPoint is. But to me, I think that the biggest thing is how familiar the developers working on the code are with their code base. That's the big, that ends up being the big variant. And as the code grows larger, it's harder to keep up with what's going on, and it's harder for people to understand it. And
so maybe that's what you need is better tools for code to understand.
Pardon?
Maybe what's needed is better tools, not to allow the compiler to understand the code, but better tools to allow other human beings to understand the code.
Modularity.
I agree. Look, the
complexity of what?
No, you need something between code and what for you exists only at the level of verbal description. What you call
Absolutely, yeah.
You need rigorous specifications which give you intermediate levels so that the programmer can know what to call this basis at a higher level, because he cannot allow himself to learn 100,000 lines of code. But he could maybe learn 10 pages of an abstract description.
Yes. Yeah. Yeah, I agree with that. I mean, clearly that we're, I don't want to say we're pushing the limits of the complexity of the code we have, because people were saying that 8 years ago, and that was used as, arguments to rewrite, to start rewriting all sorts of, we had some huge failed attempt at rewriting Word, for example, back in, the Word 2 days. And back then the predictions were that we couldn't ship another version based on that code base, and we're still going.
Is that rewriting completely abandoned?
Completely.
So it's just dead?
Yeah. Yes?
Look, it's nasty, but it's not intended that way.
No.
See, I think rewriting the word, as you say, wouldn't help, but what would help, or could help, for the problem you mentioned, if you come up with a description of what certain parts of work do, which allow me to understand it without going to the code, then you would win. Because the new people who come, who don't know how it was done, they read this rigorous specification, not the code, and they rely upon that understanding. And if you do it well, then it's fine.
Somehow the problems to me seem to occur at a much lower level than that, though. The problem.
No, there are intermediate levels.
Absolutely. I mean, there are problems at every level, right? But there's a lot of unfortunately there are a lot of details you need to know to how to use sort of the core engine in Word, right? A lot of details you need to know how to call the APIs properly. And
So here are two people. They have investigated a piece of code which was tens of thousands of lines, and they made rigorous descriptions of abstract representations of this, which are in the order of magnitude of hundreds or small number of thousands. And that's what one can understand.
You guys want another piece of code to work on? If you want another piece of code to work on, let me know.
I didn't understand.
If you want another piece of code, which piece of code did you do this with?
We worked with some of the Com Plus.
Oh, okay. Try.
Pilots.
What's that?
It was a pilot.
We love having people pilot stuff on our code, frankly. Well, no, because part of our experience, and this is the experience we've had with Bounce Checker and stuff like that, is that there's all these great things that somehow seem to break apart with our massive our sort of old, chunky, massive source code. And it's great. We love it when people use parts of our code to do some of these pilots and experiments and prove to themselves and to us that they, I think they're actually very good real-world tests. But maybe not, actually. They're probably not, they're not your typical source code base. They're probably kind of bigger than, but
if you can handle that.
Yeah. Okay. Too much the performance roller coaster. We talked about that. Schedule predictability. This is just one of those. This is just another way to say scheduling is hard. I talked about that earlier. Also, it's very hard to take into account everything that you need to do when you're going to create a feature. It's a combination of incomplete specs. It's a combination of sort of you don't know everything. You don't know every snag you're going to run into because the architecture of the app is complicated, and you can't design everything up front. We've tried coming up with checklists of everything you should think of when you write a schedule. They're worthless. And that's it. And now we have another hour for questions.